Today we're going to be making the Chutes and Ladders game in C++. This will be a command line based game, just like all my other projects, so let's get started. So first I'm going to include some of my files, so I'm just going to go to CMD and go in code and dot. So code and dot will just open up Visual Studio Code for me. Here I could add in a file. So the first file that I'm going to use is the main.cpp file. When I have defined this file, I could include some of the important header files that I need. So the first one is the IO stream. Second is the namespace. And third is the main. And then the return 0. Now that I have included this, I'll actually need to know how this Chutes and Ladders game would work. Now I'm going to have to separate out my code in multiple files so that we have the concept of separation of concerns. So let's do that right now. So I have two different files created. Here I'm going to create one for the declarations and the other one for the definitions. So this one's going to be for the declarations. So what I could do is instead of having it defined here, I'll just cross these two out and define it here. So one is going to be called the Chutes and Ladders. Chutes and Ladders .h. The other one will be called Chutes and Ladders .tpp. Now, if we go to the main logic, we need to do something that will allow us to basically roll a die. That's the first thing in the Chutes and Ladders game. So if I just give a small brief explanation of how this would work, it's like there's basically a grid and there's numbering from 1 to 100, and a person has to just go in the whole grid and has to reach till the end. So this is just like, suppose this is our grid. These are two players, and each player rolls a die. Now, if a person, let's say, gets a 5, it will go 1, 2, 3, 4, 5 spaces. And then if another person rolls a die and gets 4 spaces, it will go to its own position. If it finds a ladder, it could go and move on to the next position. If this person finds a ladder, it could go on and maybe move on to this position. Whoever reaches 100 first will win the game. There are also conditions where there could be chutes, which are slides that could make you fall down from a higher position to a lower position. So we're just going to include these kind of things as well. So now let's get started. So I'm going to actually include that. But before that, I actually need something very important, which is the seed for the random number generator. So for that, I could use static random time, and then we could just use 0. This is basically creating a random generator for my rolling die, because every time I execute this code, this could become same if I don't have this code added. Now, because of my time, which I added, this is going to give me a different execution sequence every single time I run this program. So now all we can do is include the following. So we have hash include C standard library, and we have another one which is hash include C time. Now, if I added this, my error will be gone. So I'm just going to comment out here. I'm just going to add in. I'm going to comment here and I'm going to say seed the random number generator. Okay, so now we're going to move on to the next one. Now, the other concern after creating the random number generator is the positions of the players. So we get the positions of the players really simply. Let's have the forward slashes here, and I'm just going to add in comments whenever I write the code. So I need to initialize. So the players. So I'm going to have to initialize the players' positions. So space. And then this is positions. Now, to initialize the player's positions, we have, let's say, int player position 1, and that should be 1. And then we have int player position of 2, and that should be 1 as well. Now, we actually need to make them initialize to 0 because they're going to be starting from 0 and then they're going to move on. So that's why I need to initialize the players' positions with 0s each. Now, the main logic here is actually a game loop that will run. And before going forward and getting all of that done, I would actually need to go into this chutes and ladders.h. Let's connect all these files. So one other thing that I forgot to add is this header guards. So if not define, and then we generally conventionally put the chutes, ladders, so like that, and then we have an underscore h like that, and then we have hash define, and then we have chutes, and then we have ladders, and then we have underscore h. So we have hash if not define, we have chutes and ladders underscore h, hash define, and we have chutes and ladders underscore h. Now we have this function to roll a die. So we say function to roll a die. So we say function to roll the dice. So the function to roll the dice, you just need to define the function like this. Roll dice. And this is the declaration of this function. Another function that we might need to use in the future is basically a function that would simulate the player's positions. So function to simulate the player's positions. Simulate the player's positions. So for that, we could just simply add int player turn. We have int player, and then we have int the reference of the operator, address of the operator, and for that we could have the position. So address of operator, and then we have position. And then finally at the end, we just need to have this and if this is basically defining the chutes and ladders so that it only runs one time and not more than one time, and it's only defined a single instance. That's basically the purpose of a header guard. Then if we move on to the chutes ladders.c++, which has the definitions, we just basically include the header files that we normally had, and we have to include the following, which is chutes, we have ladders, and then we have .h, and then we have the include IO stream. So IO stream, we have the C standard library, so C standard library, and we also have the C time that we have for random numbers, so C time. Now remember I said I created this roll dice function. This is going to roll the dice for me. To simulate this, let's just have the function defined here. So roll dice, and this will not basically add anything, and it will just basically return a number, right? So it would return some random number, and we're using the C standard library rand function, and we use the modulo operator. So the modulo operator is basically this one, and then we have to divide it by 6. So this is going to give us the range from 0 to 5. If we add in a 1 to each, it's going to be 1 to 5. So it's basically 1 to 6. Now it's going to be added. So that's how the random number generator would work. Initially, it would be, when I say rand modulo 6, it would be 0 to 5. And then if I press +1, that would add 1 to each area over here. And then this is going to be my range. So that's my roll dice functionality. My player turn functionality is going to be somewhat different. So how I'm going to move on from player to player is basically I'm going to get the player's number as well as the player's position using a reference operator. So for this, I could just have the return type and say play turn, and it's going to be player and also the reference operator for the position of the player. So position. we're going to roll the dice. So we're going to say roll dice, and that should roll our die. And then we're just going to say some condition that says, let's say, player roll the dice. So we say player, and then put in the variable player, and we say roll the, and then we have dice, and then we have the dot operator here just to make that it's a sentence, and then the end line here. So it just says over here, stand C out, player roll the die. I guess I didn't add in a namespace standard, so I'm just gonna quickly do that as well. So now after that, we have the the screen input message that says player roll a die. We also need to update the position. To do this, you currently have a position somewhere which was 0 initially, and then after that, it just adds based on the dice roll, right? So we're just gonna increment it using plus equal to dice. Now, there's a condition that we're gonna be checking, and remember where I had to simulate the chutes and also the ladders if they appear in any kind of position inside the whole board. So for that, I could use a switch operator to see which position lands to which. And I'm going to hard code these values out, but you could also change them according to your own needs. So basically, I have to check if the player has landed on a chute or a ladder. Okay. So we're going to use a switch statement for this. You could use anything, but I would use a switch. Now we have the position, thing over there, and over here we're just going to check if the position is, we're just going to use some random value. So let's say 4. In 4, if the position lands here, we could say the following. So I have these outputs already created. So we have, let's see. So it says player, and then we have found a ladder moving to position 14. Okay, so it directly moves to position 14, where we could update our position to 14 like this. And then we could simply break out from this case. Other than that, we have more switch cases, and I'm just going to quickly populate them. So you could change the values up according to your own needs. But you remember that you not only need for the ladders, but you also need for the chutes. So let's just add them quickly here. Okay, so now I have added all of these. So you can see on 99, we have a player, found a chute. Now moving back to position 78. So this is unfortunate. When reaching 99, you go back to 78. The last case for the break statement is actually something called, one other thing that I have to do before that break statement is a case for 100. And that is if the position of the player reaches 110. I mean, sorry, if the player reaches 100. So what happens when a player reaches 100? He should win the game. So that is the condition here. So we have player reach level 100, they win. So that's basically it. And then that should break. By default, we have to do something. So that's what I had to bring up. So let's say default. And for default case, it would say the same thing, which has standard C out. And we have player. And then we have player is now at position. And it would just locate us which position the player is currently in. The position. Like that. So that is there. Okay, so now we have our break statement continued. We actually needed to return one last thing, which is the position. So let's just return the position of the player right here. So there. And now you can see that we basically completed our definition for play turn. And this would just make the turn simulated using a roll die and updating the position over here. Now we are finally left with the last position, last portion of this main application, and that is to just allow us to display something so that we could actually visualize it on our computer screen. So we have these two player positions initialized to 0, and once we roll a die, we can move on to further positions. But let's display the board and the initial configuration. So remember I said that this game will have a while loop, and this is like the logic for the game. So it would have a continuous loop that would run until some conditions are met. There's one thing that is used to clear the computer screen, which I'm going to be using. If you're using a Mac device or also you're using a Linux device, then I would recommend standard system, and then what you would have to use is inside of this you would type in clear. But right now I'm using Windows, so I'm going to have to use CLS. So this would clear my console screen, and then after that I could display some of the message that I would like the user to see when the game starts loading. So these are some of the messages that I'd like. So I'm just saying Chutes and Ladders, just an introduction, and then after that we're saying player 1 is at position, and then it would give 0, player 2 is at position 0. After that I would like the player 1 to do its turn, right? So the player 1 has to make its turn, and remember that the player 1 has to roll a die, right? So let's just quickly add in the following. Now, if I say player 1's turn, that means I'm just gonna show that it's player 1's turn happening using the character output. But I also have to use the play turn function that I have created. So play turn, and inside the play turn we actually need the position, which is player 1, right? The play. So if we go over here, Chutes and Ladders, the player, which is 1, and also the position of that player. So that is the variable that we define, player 1 position. And after this play turn happens, actually one other thing is that play turn returns an integer, remember? And you know this very well. We have to add it to something. So I'm just gonna say player 1 position, which is the updated position. Now I'm getting an error because I might have well not defined it here. So over here, I would have to link the Chutes and Ladders. So I would say hash include. We have Chutes Ladders dot h. Now that we have included that, that error should be gone because the program now knows that that function was defined somewhere. Okay, so now we could have now the player 1 position, which is play turn 1 and player 1 position. Now I have to just simulate if the it goes on and on, it will go on and on because this is just continuous. I have to break it in some point, and I know where to break it. It breaks when the player 1 could reach the 100th position. So if it reaches the 100th or it's greater than the 100th, which in case could just make sure that these breakpoints are applied, we should break the code. Okay, and then we would just go and simulate the same for the player 2. So I would just copy this entire thing, and I would use Alt Shift and down, right? And this would copy this entire line or lines, and I would just add that. I would change this, and also I would say 2 over here, 2 over here, 2 over here, and 2 over here, and that's done. So now we have both of the players making turns, and they will be updating. But one thing that we may need to do is, once the two players make a first turn, right, in a single round, we want to pause the screen so that we allow the user to press enter to continue. So for that kind of simulation, I could actually do something. So pause for a moment, okay, before the next turn. That's what I want. So I could use standard C out, and I would say press enter to continue, and that should do the trick. That I'm going to simply do cout, and I'm going to use the famous way to, pause the screen and let for user input is cn.ignore. This also ignores the enter key, which when I press it, so that it doesn't harm any of my further, processing within this program. So when I ignore using cn.ignore, it would ignore my enter key press, and that wouldn't harm any other, inputs that I'm asking for in the future from my program. So now that this break logic is working correctly, this is how it would work, and this is how it would be keep showing, and continuously it would be clearing the screen every time the new round happens. So at the end, finally, when you're done, you would want to clear the screen one final time. So I would just use the same standard system, and we would say CLS. And the last thing that we would want is displaying the final positions of the game. So that would just be the following. Again, this code will be linked to my GitHub repo, so you could get it and check it out. So display the final positions. We have chutes, ladders, and then game over. So pretty much that is it with this code, and I might as well start running it. So this is the entire application. Okay. So what we're going to do is we're going to go to our file explorer, and we're going to go here, and we're just going to run it. So you can see over here, chutesLadders.h. We have chutesLadders.cpp and the main. So this is the main logic, the header file declarations, and the definitions. So I'm just going to go here in the command prompt. I could type in cmd. This would open up my black box, and I could type in here the following. So I would say G++, which is the compiler. So G, so I would go G. So I would go G plus plus main dot cpp, and then we have chutes ladders dot cpp, and then we'd have the -o flag, which is used to run, change the executable, and let's say run. And there you go, we have this executable, and now let's run this program, and we have our program running. So you could check here, we have chutes and ladders. Player 1 is at position 0, player 2 is at position 0. Now we have player 1's turn, player 1 rolled 2. Okay, now I actually need one kind of fixed over here. Player 1 and player 2, they're having, they don't have spaces. So let me just fix that out. So player 1 rolled a 2 or something. Let's see. Go back to the main logic, and here there should be player 1 rolled or something. Let's see. Okay, so actually it's in the definition here. So player Okay, so over here, it should be a space. So I'm just gonna add in a space here. And one space. That's it. Let's just save the code, and I'll rerun it. So I'm gonna say So I'm going to say this following: G++ main.cpp chutes and ladders.cpp and then -o flag run. This is just going to overwrite this existing one, and that should run it. So now I'm just going to type in run, and this is our program. So we have chutes and ladders. Player 1 is at position 0. Player 2 is at position 0. Now we start by player 1's turn. We roll the die, and it basically got 1. Now player 1 is at position 1. This should update in the next round. And then we have player 2's turn. It rolled a die, and it got 5. So player 2 is at position 5. Now if I press enter, remember the CLS thing would work, and also the updated positions would work here because of the control code that I have. So I'm going to press enter here, and now you can see 1 and 5 have worked, and you can see now player 1's turn is 3. Now roller 3, what happened was 1 and 3 turned into 4, and now player 1 found a ladder moving to position 14. Wow, a bonus. Now player 2's turn, he rolled a 2 and got a 4, and it also went to found a ladder, and now it went to position 31. Now these 14 and 31 should also be updated here. So after that enter, you can see that these are updated, and now the player 1's turn rolled a die, turn 3 and found a chute. Now it would go down to 7. This would go 3, and it would go up to 34. So it's just gonna keep going, and you can see now it's moving up. Player 1 found a ladder, it's moving up. So let's see who wins, player 1 or player 2. My guess is, let's say, player 2. And now then you can see, okay, so player 2 is going, player 2 is going, player 2. Okay, cool. Okay, 91. Player is at 91, and player 2 is at 91, and player 1 is at 75. Player 2 is at 94, and oh, it dropped out. It went to a chute. It's going back up. It's going back up. Oh shoot! It found a really bad chute, which is a slide, and it would go to 24. Now you could see it's moving, and I would say that player 1 is winning, and it's leading, and it's 94, and there you go. Player 1 is at position 100, and player 2 is at position 79 at the end, and the game was over. So this is the simulation of the Chutes and Ladders game in C++. Hope you really love this program. It's pretty simple, pretty basic, and it's just using the clear screen to clear the screen after every single round. And you can see now, initially I thought player 2 was going to win, but at the end player 1 did win. So finally, this program was done. You can find the code in my GitHub repo. Remember to like and share this video to your friends. If you want more such content just like this, then please subscribe to the channel. That would really help, and I'll be looking forward to making more videos. Thank you guys, and have a great day.